Hey guys, my name is Jason with Mount Baker Mining and Metals, and this stuff here is ground up printed circuit boards out of old computers and electronics. It's mostly copper with some other industrial metals in it and a little bit of gold and silver. So what I want to do on today's video is do some experimenting, try and get this stuff melted down into a product, either a block or a bar, something like this, that we can then use some further chemistry and electricity to electrowin the copper, get the precious metals down in the bottom, where we can then refine them to a precious metal product and then sell the other industrial base metals. So let's get the furnace fired up here and see if we can get this stuff refined down into something usable. So I wanted to give you a closer look at this stuff. And I just did a video here not too long ago, a couple weeks ago, that shows how I got this stuff. And I'll put a card or a little link to it up here in the upper corner. But this stuff is just all the metallic fraction from ground up circuit boards. And there's a lot of copper in here. This stuff's about 85% copper. There's a little bit of lead. There's a little bit of tin. There's some aluminum. There's some steel. And there's a little bit of gold and a little bit of silver. But the ultimate goal is to pour bars that are mostly copper, like 98% copper, with a little bit of precious metals in them, that we can then hang in a solution of copper sulfate, electrowin the copper away into pure copper bars. The precious metals will fall down to the bottom of the tub, and then we can do some further chemistry to refine those into precious metals. But our first goal is we got to get rid of all this junk. There's iron in here we don't want. There's zinc in here we don't want. There's aluminum in here we don't want. So we're going to use some fancy chemistry and really high temperatures to make that happen. So the first thing we got to do is we got to go over our metal reactivity series. And this is abbreviated. You can look for a full list online. But basically, the idea here is that there are less reactive elements at the top and more reactive elements at the bottom. Now, most of these metals we're going to encounter in our ground up circuit boards. And these are the three that we really want. We want the gold, silver, and copper in the finished product, in our bar that we can then electrowin the copper away and get our gold and silver. We've got to get rid of all this other trash. But there's still a lot of value down here in some of these base metals. So even though we're going to, quote unquote, get rid of them, we're still going to save them, and we're going to try and recover them after we get these in their final bar phase. The lead, tin, and nickel are probably the three that we can deal with. Iron, zinc, and aluminum, there's probably not enough in there, and they're not worth enough to want to go after. And what we're going to do is the first experiment, I'm going to take lead oxide, which is one lead atom and one oxygen atom. I'm going to put it in the furnace with borax, and I'm going to add iron to it, metallic iron. The iron is going to pull the oxygen off the lead because it's more reactive. And what I'm going to try and do is convert this lead oxide to lead metal, and the iron's going to turn into iron oxide, and if we have enough left over, it'll be a little bit of an iron nail left, iron oxide dissolved in the borax slag that we're going to make, and a lead puddle at the bottom that we're going to pour off and recover our lead metal. But what we really want to do is get rid of the lead and get rid of any bismuth in there. So the second experiment I'm going to run is with copper oxide. And the idea is that if I add enough copper oxide to our crucible and fire it with this whole suite of metals in there, the copper oxide is going to react with all of these other metallic forms of metal, and they're going to oxidize all these, which we can then dissolve in our slag. The copper is going to go into copper metal, silver, and gold, which won't react with the copper oxide. And we can pretty much draw a line, hopefully, at copper. Everything underneath will oxidize. The copper oxide will turn into copper metal, and we'll get gold, silver, copper, platinum, palladium. They're all up here as well. So that's the first two experiments we're going to do. And if we can prove that those work, then we'll start experimenting with our actual PCB metallic stuff that we have, and we'll see if we can actually put this to work. Well, I won't bore you with all the math and the chicken scratch on this piece of cardboard, but we put in 40 grams of copper, and we end up with 34. That's 85% recovery. And we put in about 47 grams of lead and ended up with, what did I say? 41. So that's 87%. So we got, right around the same percent recovery on both of them. This one was in 15 minutes. The copper was in half an hour. Why can't I recover the last 15% of our base metals? Somebody answer me that. Well, here's a little something I was playing with, and I'll show you guys. This may have been where our copper and our lead went. I don't know if you can see that, but these are the nails that I put in with the copper. And look, they're all coated. Once you get the slag off, they're all copper coated. So I bet that is where the rest of our copper and lead went, is it stuck to these nails. It can't pull itself off these nails. So that's probably where all the base metals went. But now let's move on to this problem, because we have proven that we can reduce the copper and lead based on our reactivity series. So in theory, if I put in the right amount of copper oxide with this stuff, we should get a pretty pure copper button. All right, now what we need is a control. And so what we're going to do is we're going to try and smelt these down directly to figure out how much metal we can recover from 100 grams of these parts. All right, there's 100 grams of computer parts and 200 grams of borax. We'll get that mixed up. We're going to put it in the furnace in a crucible, melt it down, and see how much metal we can recover, and if we can get a nice bead. In the past, I've done this, and we don't have a very nice bead at the end. It ends up being all kind of junky and a bunch of stuff on top, but we'll try it, see how much metal we can recover, and then that'll tell us how much we lose during the smelting process, how much we need to add of the copper oxide to try and clean it up and get mostly copper and precious metals. All right, well, here is our button that we cleaned up from just our straight 100 grams of computer parts. And it's interesting, it's not very dense for how heavy it is. I think it's full of bubbles. It doesn't look very good. It's all pockmarked and different colors and bumpy and lumpy. So this is not what I would call a success. Let's see how much it weighs here and see how much we lost. So again, we put in 100 grams. We ended up with 84. So we lost 15 grams from reactions with the borax. You can actually look at this stuff. It's all rusty already. So there's probably a bunch of oxides in there as is. And so I'm not surprised we lost 15 grams. I didn't put any iron or no nails or anything in there. But this is our baseline. This is our base mark. That's what happens when you just melt it with borax. You get 84 grams of junky looking stuff. Now let's figure out how much copper oxide we can add to clean that up a little bit. Okay, so I got 100 grams of computer parts. I've got 200 grams of borax. I was going to add 15 grams of copper oxide, but a big blob of it came out, so we ended up with 20 grams. So we got 20% copper oxide by weight, and that's copper 2 oxide, so it's 1 copper atom and 1 oxygen atom. So let's put that in the furnace and see what we come out with. Well, I'm gonna rush this a little bit. This is the stuff we added with copper oxide. It's not quite cool yet, but my furnace is still hot, and I'm going to reprocess the slag. So let's see if we can. Uh-oh. Come on out of there. There we go. There's our stuff. Now what I'm going to do is I'm going to do this kind of quick. I'm going to knock off the metal button, and then the slag I'm going to put back in the crucible with iron nails and try and reduce back out all the metals that we oxidized with copper oxide. And looking at our chart, it should be, there's probably not any bismuth in there, but lead, tin, and nickel should come out of solution. The iron will stay in solution as iron oxide. The zinc and aluminum will also stay in solution. So let me get that knocked off of there, and we'll put it back in the crucible, back in our hot furnace, and see how much base metal oxides we can reduce. There's our crucible, our slag's in there, and I just added 5 iron nails. Okay, what we have here is the slag that I've reprocessed with nails. There should be a little tiny button in here somewhere. Let's see if we can find it. All right, so this is kind of interesting, and I need your guys' help to figure out what's going on here. This is the slag. It's super black on the inside, reddish on the outside where it touched the iron cone mold. And I've had comments in the past that people think that when I pour that hot slag into the cold cone mold, that the copper in the slag reacts with the iron and forms this little skin of red copper that comes out of the slag solution. So is that what's happening? Because I don't have any metal button at all. And I don't know if you saw in the video, I accidentally dropped a nail in there. And here's the nail. It was covered in slag, so it's nice and shiny. And I think you can see the head of it's a little bit smaller. The shank down towards the head is a little bit smaller. I think it was sitting down in the crucible, head down. I think what may have happened is we had so little base metal oxides in that slag that they've all kind of glommed onto this iron nail. And just like we saw when we did these previous examples with the lead and the copper here that we reduced to oxides, we were missing 5 or 6 grams, and we had 12 nails, so that's about half a gram per nail. I put 5 nails in this time, so if you calculate that out, there'd be about 2.5 grams of base metals. But we added 20 grams of copper. We added 20 grams of copper oxide. Got these 2 buttons. I don't know if I've done this yet. Here's our 2 buttons. That's the first one with just borax, 84 grams. Here's the second one with the copper oxide, 82 grams, roughly about the same. I added 20 grams of copper oxide in there, which ends up being, I think, about 15 grams of copper metal. So we should have reduced at least 15 grams of either base metals or copper with these nails, and I don't know why we didn't. Here is the XRF results from our first control button. This was the computer parts with no oxide and no iron. And you can see it's mostly copper. There's a little bit of nickel, iron, and zinc in there. Silver actually shows up. Then you see tin makes up about 8% of the button, and then lead brings up the bottom at 2%. This is a good example of just run-of-the-mill PC boards and the metal concentrations that they have. Here's the second button we did with the copper oxide, and you can see immediately that the copper percent went up. It's about 92.5% now. But interestingly, the nickel was pretty much untouched. The nickel hasn't been affected at all. The iron has been reduced effectively to 0. Silver is still there in about the same concentration. Tin has been reduced by half, and lead has also been reduced by about 75%. So the copper oxide did do something, but I don't know if it achieved the complete goal that we wanted it to, which was completely remove all the base metals other than gold, silver, and copper. So help me out, guys. I'm not quite sure what happened. We're losing base metals somewhere. We're losing oxide somewhere. I don't know why the iron didn't reduce anything out of that slag that we reprocessed when we did the computer parts and the copper oxide addition to the flux. But help me out. Why won't this work? Why can't I convert the base metals, the lead, the tin, the iron into oxides and then recover them again, just like we did with the previous chemistry? I don't know what's going on. So help me out, because if we can crack this nut, if we can get this figured out, and I can concentrate all the precious metals in the copper, eliminate all the other base metals, and reprocess them afterwards in the crucible, and recover them again, sell them for the values that they have, you can have this full circle, complete process where you get the valuable copper clean, you get the valuable precious metals clean, and then you have a base metal ingot or doré that you can sell off to whoever is going to buy that if you have bulk. Now, another thing I want to ask you guys, and this is each person's opinion about how to do this. Some people, they take their boards, they put them in a box and they sell them just as boards, right? Other people, we've sold lots and lots of equipment where you can take the board, throw it down the hammer mill onto the shaker table. Just like that video, I put a card in the top corner at the beginning where they process the boards, they get their base metals, they get all the metals across the table, the fiberglass and the plastic go down off into the tailings, and they have their metal concentrate that they sell. Other people take that stuff and they process it through acids, they take it down, they recover the base metals, they recover the precious metals. Some people smelt it into big bars and sell it as bars, as mixed metal bars. And I have other customers who want to separate out each individual metal. Some use chemicals, some other people use pyrometallurgy like I'm trying to do. What, in your opinion, is the best way to process these computer boards? Is it sell them direct to refiners as whole boards? Is it process them some, get the metal out that you can off the shaker table and sell that? Is it process even further and refine some of the metals out, the copper, the silver, the gold, some of the more expensive base metals and precious metals? Or do you try and get every single metal out and refine it all the way to completion and sell it that way? And remember, this whole process wouldn't be a hobby process. This wouldn't be 50 pounds of boards or 100 pounds of boards or 1 ton a month. This would be a process where you're running tons and tons a month and you have lots and lots of metal. Are you going to process it yourself, or where along the stage of processing are you going to sell it? That is my question to you guys. But we're going to call it quits for this video. I hope you guys enjoyed it. I'm looking for some help on this, so any additional help or comments you guys have, please leave me a comment in the comment section below. Otherwise, thanks for watching, and we'll see you on the next video.